In this video, I'm going to talk about this paper on theory in operations management. I make a separate video for this paper because I feel it's really important and I want to illustrate certain things in the paper using diagrams and slides. So let's get started. If you look at finance, a lot of financial models are built on economics theories, which explain the fundamental behavior like efficiency of financial markets, information asymmetry, things like that. Organizational behavior is built upon theories of psychology, about motivation, about responding to incentives. Operations management doesn't have a single foundation where we can say this comes from this area of social science applied to business. We could say it builds on some microeconomic theory, some behavioral stuff as well. So it combines a lot of areas, which is why sometimes people feel that it is atheoretical. It's just doing these different things and doesn't have a solid foundation. However, that was mostly in the past. These days, there's a lot of theory in operations and supply chain management, and it has developed a lot of its own theories. So we're going to look at some examples of that, some classical examples, which have been established now for a while, and hopefully you'll be learning some new examples as you do readings for your research for this course. So what is theory? A theory is a systematic explanation of why and sometimes how. Okay? So why does certain phenomena occur? For example, there's the question, why do companies adopt certain practices? You might have noticed that something becomes popular or a fad and every company is trying to do it. We started the quality movement. Everybody wants to do TQM. Everybody wants to have ISO certification. Everybody wants to do XYZ, right? So why do firms adopt certain practices? And one theory which explains that is institutional theory, which says to gain legitimacy, firms want to appear legitimate, like they're serious about what they're doing, and adopting certain popular fads helps them get there, whether those are relevant for them or not, to gain legitimacy, right? This explains why. And then how do firms become similar to each other over time? That question is also answered by theory, because this says that there are certain pressures in an industry or in a context that apply to all companies, and these pressures bring these companies together. For example, all manufacturers may have ISO 14000 or 9000 certification. Right? So theory answers the question why, and sometimes it answers the question how. It offers an explanation for patterns and relationships we may observe, and it's often trying to provide a causal interpretation. So we observe Y because X leads to Y. It also provides predictive and interpretive power. You can interpret certain behaviors, and you can predict that if X happens, it's likely Y will happen. Or if more of X, then it will be more of Y. Or in a certain condition, X will lead to Y, things like that. Prediction doesn't mean prediction of the future. Prediction means if certain conditions hold, something else will increase or decrease. Right? It's not necessarily about the future, but it says if these things happen, if these things are true or these things are happening for a company, then it's likely that this other thing will increase or decrease. A theory should be at the conceptual level, not just concrete events. That the financial COVID, for example, lockdowns in COVID led to companies investing in online platforms. Okay, now this is not a theory because it's particular to specific events. But if you raise the level up and you say, disruptions in transportation or disruptions in ability of people to gather, or just supply chain disruptions in general, will lead to firms developing alternative channels for sale. Now that could be a theory because it's dealing with concepts, not a particular situation. Theory should be testable. It should lead to hypotheses that you can find variables for to test the relationships in those hypotheses. It should be testable. So you should be able to do an empirical test. It should be empirically examinable. Okay. It should be generalizable. It should not just apply to one case or setting, which is kind of like, if it's abstract, that leads to generalizability sometimes, but the theory should not be so specific that, under these 100 conditions, which basically lead to just one firm in one industry, this happens. That's so specific that you can only talk about like one firm, right? You should be able to generalize to multiple firms so that it has a value to other people. Okay, we have to, I think the paper does a good job of differentiating probabilistic knowledge because this is a confusion I see a lot of people have based on their training in natural sciences. So I think most people will study natural sciences in high school, physics, chemistry, and then they use that lens to look at everything else. So in natural sciences, things are not probabilistic because if you drop an apple and it flies upwards instead of falling down, then the theory of gravity has been falsified. Just one example. So one example can falsify an entire theory in the natural sciences. One contrary example, right? Not so in social sciences. In social sciences, things are so complicated that we're never able to capture all the variables. And so our knowledge is always approximate. So if a theory works most of the time, which is better than chance, so better than 50-50 or whatever equal chances for that case, if it improves in chance, then we can say it's a theory because it allows us to make predictions that go beyond natural chance. Okay. So that's why sometimes people say in social sciences, exception proves the rule, because if the contrary example to the theory is an exception, then we are admitting that it's not the norm, because what is the norm is not termed an exception. If you term something an exception, that means that's not the norm. And so theory still holds. The theory will continue to hold unless the exception, the contrary exception, becomes the norm, becomes the majority case. As long as it's the minority case, that's only proving the theory because what's supporting the theory is the norm. Okay. Medical science is mostly probabilistic as well because the human body and its environment are very complex and have very complex interactions. Again, it's very hard to measure all the variables, right? So we know germs lead to infections, but not every exposure to germs leads to infections because there's so many other variables that will determine whether infection happens or not in addition to presence of germs, right? Vaccines work in a probabilistic sense, but some vaccinated individuals will catch the disease. That's not disproving medical science because what we have is probabilistic knowledge, right? So just like these examples I talked about, what we do in management and social sciences is we develop probabilistic knowledge. Okay, so what's the role of the theory? Theory can lead to development of hypothesis, although you can have hypotheses outside of theory as well. You could just observe some patterns and you have no theory and you can make an hypothesis that will then lead to theory. So sometimes you have theory and then you extract hypothesis and you're testing the theory by testing the hypothesis. But sometimes you develop hypothesis just by observing patterns or observing some examples like case studies. You extract hypothesis and then you test the hypothesis. And then if these hypotheses hold, then your explanation for the hypothesis becomes like a new theory. So you go both ways, theory to hypothesis, testing to confirm theory, or from some examples to hypothesis, which then confirm, then lead to theory. So we go both ways. It helps us make sense of complex environments, answer why and how question, predicts what is likely to happen under various conditions or environments, and summarize existing knowledge about a phenomenon. Okay, so let's look at theory and operations management, which is what this paper is about. The classic question of management is to explain the variation in performance of companies. So how can two companies which look very similar are in the same industry serving the same customers, one is making more money than the other, right? What explains that? And the reason this question is so important is because before management, economics is an older discipline. Economics said that profitability of companies is explained by industrial economics. So is there perfect competition? Is there monopoly? Is there oligopoly? How many firms are competing for the same customers? Maybe things like capital intensity or economies of scale. So if one company is much bigger than the other, it has economies of scale. So they had these sorts of theories, but what we saw was most of the performance variation between firms exists within industries. narrowly defined industry. So even within a narrowly defined industry where companies tend to be very similar on economic parameters, like they all have the same industrial environmental conditions, they all have the same level of competition because they're all competing with each other, and so on and so forth, and they have all the same capital intensity, but still their profitability is different, right? So the economics is not able to explain variation in firm profitability adequately, or even more than 50% of it. So it's very limited. Economic theory treats production, firms, factories as the black box. So it's always looking at the industry structure, competition, economies of scale. It's not going into how production is actually done, right? And so then management comes along and says, okay, let's open this black box up and let's explain why are these firms having different levels of performance, right? So that's management in general. When we look at operational performance, things like quality issues, safety, ability to handle different volumes, customizability, cost efficiency, all these supply chain and operations performance parameters, explain variation in those outcomes, then that becomes the central question of operations and supply chain. So we're going to look at two examples of theory in operations and supply chain. The first is called the theory of swift even flow. And this theory kind of ties together these 5 laws or patterns that were observed. Now, some people will call some of these laws or patterns a theory as well, because the explanation of that pattern does answer a why question and does have predictive power. It will explain what happens in certain conditions, right? So this article tends to differentiate between laws, which are observed patterns, and theory, which explains those patterns. But sometimes when people talk about a law or a pattern, they're talking about the explanation of the pattern with it, and they're also making a theoretical argument. So I want to warn you that I'm presenting this slides as the article present that, but it's not universally agreed upon. Some people will call these laws as theories as well. So let's look at law of variability. Law here does not mean that it holds 100% of the time. If you're talking about probabilistic knowledge, law just means a pattern that we have observed. So more variability leads to lower productivity. If you have the same assembly line and you make it produce like 50 different things, it's going to have less productivity than an assembly line produce the same product day in, day out, because specialization, they get better, there's learning effects, all sorts of things. Also, they have less switch over time. They don't have to change equipment. They don't have to change workers with different skills around, so on and so forth, right? Law of bottlenecks, if you have different capacities within a production process, then the lowest capacity unit will drive the capacity of the whole process. It's like this chain is as strong as the weakest link. And to improve the productivity of this process, you'll have to really focus on the bottleneck, also known as theory of constraints. If you want to learn more about it, there's a book called The Goal, which is required reading in my master's operations management class. And if you are interested, you should read it. It's a very interesting book called The Goal by Ellie Goldratt. You can buy it on Amazon or get an audiobook. It's a fiction book. It's like a fiction story which explains this theory of constraints and issue with bottlenecks very nicely. Law of scientific methods is mostly about standardization and timing, do time motion studies, standardize tasks, right? And one of the classic examples in this is McDonald's. Before McDonald's, it was very hard for the food industry to maintain taste and quality when you tried to take what worked in one location to multiple locations. There were many famous restaurants around the world where the chef was very famous. People went there to eat. But when that restaurants tried to expand into multiple branches, hired more chefs, the taste and quality would not match the original establishment. And so you didn't have these fast food chains or just regular restaurant chains because it was very hard to maintain taste and quality across different restaurants of the same name, with the same overall top management. And so McDonald's said, let's engineer and standardize everything. So what type of potatoes we're going to use for our French fries, how they are cut, what's the oil we're going to fry them in, the temperature of the oil, the time spent in the oil, everything was automated and standardized, and that allowed them to have the same taste. So if you go drive around the USA, the McDonald's fries should taste roughly the same and have about the same quality because they've standardized the process, right? Same with burgers, exactly how the patties made. They went to great lengths, and it's a very good example to study how they use scientific methods of production, which means now scientific is not used in the general sense that we use the word scientific. Scientific management was a whole movement which was about measuring activities, specifying things in detail, standardizing processes. And so when I say scientific methods, I don't mean scientific methods like in the physics lab, I mean the management movement about standardization, about measuring time, measuring things, standardizing tasks, having clearly defined processes, that management movement. Again, not like a physics and chemistry lab. That's what we mean here by scientific methods. There's a movement called scientific management, exemplified by Taylor. I forget the full name, and then the Ford assembly line is an example of that too. Law of quality, better conformance quality or better reliability leads to high productivity. So this is not quality in terms of features or quality of materials. It's quality in terms of meeting specifications. So you have a specification, and if you meet the spec the first time, everything is within spec. That's going to lead to higher productivity. And then the law of factory focus factories or units within factories which are focused on one type of product, one type of process, are going to do better than something that tries to be everything at the same time. Which kind of is an extension of law of variability, because if you don't have focus, you have more variability. So I think the first and the fifth laws are kind of, two sides of the same coin almost. Just at different levels, because factory focus is the level of a production unit. Law of variability can apply at any level within a factory, at a desk, at a production station, and this is at the level of the factory. Okay, so these laws together we call theory of swift even flow, which kind of ties these laws together and kind of explains why they lead to more productivity and better performance. Okay, so the underlying concepts that the theory of even flow uses to explain why these laws lead to better performance are value add work, non-value add work, and then what's non-value add work is called waste. You might have heard of this in the lean methodology as well. Value add work is work that directly transforms a product or service in a way the customer is willing to pay for. Okay, so let's say you try in one step of the process, you make a mistake and then you have to redo it. Customer is not willing to pay for your mistakes. Customer does not want you to make mistakes. So that's not value add work. So any rework, any scrap, any waste, any inventories, because customer is not paying you to just keep raw materials around. They only want to pay for the raw material you use for their particular good. So you have to really be careful about all the things you're doing. So in lean methodology, we go and we look at work and we classify work into value add, business non-value add, and then non-value add, which is waste. We want to eliminate all of non-value add. We want to minimize business non-value add, and we'll just keep value add to remove waste, right? So what the theory of swift even flow says is that these are law of variability, bottleneck, scientific methods, quality, factory focus. All of these lead to reduction in waste, which leads to reduction in business non-value add. So let's say you have less inventory, you have less things to document, to keep track of, right? So reduction in waste, you have less rework, you have less scrap write-off to sell or whatever, right? So reduction in waste often leads to reduction in business non-value add as well. Also, these also directly lead to reduction in business non-value add. These reduction in waste and non-value add lead to swift even flow, where everything is just value add activities and material is flowing at a regular pace through the process. There's no bottlenecks, there's no hiccups, which leads to advanced higher productivity. Okay, so that's the theory. If you want to understand this theory in more detail, this is a great book, Factory Physics by Wallace Hopp and Mark Spearman. Okay, then the paper talks a little bit about theory versus framework. It says framework is an organizing structure for observed pattern. And what's the difference between theory and a framework? Framework doesn't have to explain why. So this picture here is explaining why. Like, why do these 5 laws lead to high productivity? Because this happens. Okay, so framework doesn't have to explain why. It doesn't provide causal explanations. Some frameworks do not make predictions or provide causal explanation, right? But some do. So it's not a distinct boundary. Some people call something a framework, but what they really have is a theory as well, because they are explaining the why and they are making predictions that if you do this, you will improve on this and things like that. So in practice, there's not a strict delineation between the two on how people use these terms, but the paper makes this distinction. So just be careful if something is explaining the why and it can lead to testable hypothesis, and it's making predictions that if X goes up, Y will go up. It is a theory. Okay, so the classic example of a framework that the paper gives us is this product process matrix. So in one dimension, you have the variability in a process flow, which is the process structure. So if you have, a flexible process that changes how things happen in the process or how different products flow through it and makes many different products, it's called a flexible process. It'll tend to have high unit cost. Or if the process is very standardized and it just handles a few unit types of product, it's very standardized for them, it'll be a rigid process or structured process. It'll have low unit cost. So that's process structure. On the top, you have customization versus volume. On the right, you have high volume, high standardization, low customization right here. And then on the left, you have differentiation and customization and low volume, not low total volume. This is low volume per product that you make. So if you are customizing, okay, like movies, every movie is different. So every movie has a volume of 1. It's the lowest volume. You can't go lower than that, right? So legal cases, every legal case is different. So every legal case has a volume of 1. Okay, every movie has a volume of 1. It's volume per product, not the total volume. Okay, and here, like an oil refinery produces the same type of oil, like in millions, billions of barrels. So there's high, very, very high volume per product, per type of gas or oil that it produces, right? And then you have things in the middle. Yeah. So what this product process matrix says is you have to be along the diagonal. So if you have standardized high volume per product situation, you go to continuous structured processes with continuous flow. If you have high customization and low volumes, you go to flexible processes like job shops, which are more like project focused work, where you make something and then you make something else. So you have general purpose equipment that you can use to make many things, like a workshop. Okay. And here you don't have general purpose equipment. In continuous flow assembly line, you have very specialized equipment that does one thing very well. Okay, and this is a framework, but it can be a theory because it can explain why being on the diagonal is better. Because when you're off the diagonal, you're doing things suboptimally. You could reduce your cost by coming on the diagonal. Like you can get the, let's say you are using. You're producing something that is customized with low volumes using an assembly line. There'll be so much setup time and so many changes between small production runs that you'll be better off doing it this way, right? So you can find explanations of the why it's better to be on the diagonal, and you can make a prediction that the more you're on the diagonal, the better performance you're going to have versus companies which are off diagonal. There are contrary examples with flexible automation, where you can have general purpose robots which can build many different things and also be very efficient, like an assembly line. And that's the promise of flexible general purpose automation, like Tesla bots or other robots like that, if they can get to that stage. And we have yet to see that, but you could have some examples off diagonal, but most of the time you'll see companies operate on the diagonal. And usually when they're off the diagonal because they started on the diagonal and then the market situation changed and now they're trying to get back on the diagonal, right? So this is a framework because it's like descriptive, but you can add on the why and reasons to it, and by adding on a souped up version of the framework can be a theory. Let's do an example 2. This discussion, we'll be reading some papers on trade-offs. It'll become more clear when you read those papers, if you have not read them yet. But there was this huge discussion between two competing patterns that were observed. Okay, and they were kind of treated as theories in that time, the theory of cumulative capability. So this paper calls it a law, so I'm treating it as a law here, like an observed pattern. But there was some explanation as to why this is happening, and with the explanation, the people pushing forward this would consider it a theory as well. So the law of trade-off said that you can't be world class, like the top in the world, on every single dimension of performance. If you are the most cost efficient, you're not going to have the most variety. Okay. And if you have the most variety, you're not going to be the most cost efficient. If you're the most cost efficient, you're not going to have the highest flexibility to do customization and so forth. If you have the highest flexibility to do customization and so forth, you're not going to be the lowest cost, right? So you can't be the best in every dimension. You have to pick and choose. And then the law of cumulative capabilities would say, no, we observe these companies that improve simultaneously on multiple dimensions. So they're improving their quality and their flexibility and their cost at the same time. So if there were trade-offs, that will not be possible, right? And so these are competing theories clashing with each other. The law of cumulative capabilities are or the theory, as the original authors of that theory would like to call it, said you first have to improve quality, then you go for delivery, which is reliable delivery, lower lead times, faster delivery, then you improve on cost, and then finally you go for flexibility once you've got delivery, cost, and quality down. But later work found there were different sequences possible. There's not one sequence. Different companies go through different sequences to improve on all 4 dimensions at the same time, or without trade-offs, without trading off one. Because the trade-offs would say, okay, if you're improving on delivery, you're going to be going down on cost or going down on flexibility or something. Like you can't go up on delivery without going down on something else, right? And so we came to the theory of performance frontiers or efficient frontiers, which kind of ties these 2 together. So this is the theory, okay? If you're on the efficiency frontier, which is this blue line right here, so if you're in position C, you can move along the frontier. You can go to position D, where you become more cost efficient, but you reduce your variety. So let's say you're producing 10 different SKUs. You cut down the low selling SKUs and you only focus on the 3 top selling SKUs. So you go from C to D, you become more cost efficient because now you don't need extra equipment for the low selling SKUs. Your workers are going to be more specialized, right? But you gave up on variety. So you can move along the frontier. Or you go from C to B, you add even more SKUs to target even more different niches in the market, but your cost of manufacture per unit increases, but you're having more variety, right? So you can go from C to B or C to D, that's moving along the frontier. That's called positioning. You're positioning along the frontier and you have trade-offs. So the law of trade-off holds along the frontier. But if you're in position X right here, you're below the frontier, you can go towards the frontier because you're so bad that you're being dominated by firms on the frontier. You are poor in cost efficiency, you're poor in variety. You have less variety and you are low on efficiency because you just don't know how to do the thing very well. Maybe you're a new company, you're a startup, you just entered this business, you're just learning the ropes, or for whatever reason, you just had poor management, which happens a lot. All the managers don't like to admit it. They always try to say they are doing a great job, but there's a lot of poor management around for all these reasons, or you just have old technology, things like that. You've not upgraded your technology, you've not upgraded your capital, your equipment, your capital intensity is low, things like that. You could be at X, right? And then you could move towards the frontier and move and increase your variety and cost efficiency at the same time. So imagine this is somebody building stuff with hand and hand tools, and they suddenly start investing into automated equipment and an assembly line, and now they can do more, be more cost efficient and have more variety at the same time or something, right? So just improve their technology on what is already there out there. You can just buy the technology and implement it. And so you move to B. So that's called improvement. You improve. This is the law of cumulative capabilities. You're going to improve on multiple dimensions at the same time and not experience trade-offs. So because so many firms are below the efficiency frontier at any given time, so many firms do not experience trade-offs. They can improve on multiple dimensions at the same time, which is what these guys here, cumulative capabilities guys, were observing. And then the guys who were talking about trade-offs, they were observing firms on the efficiency frontier. Okay. Now, sometimes there'll be a technological improvement or a new way of doing business that will just move the whole frontier out. So firm B invents a new way of doing business or invents a new type of robot or some technology, and now they move to position B1, where they, even though they were on the efficiency frontier, they should only be doing positioning, they should be experiencing trade-offs. They change the technology, they change the rules of the game, and they move the frontier up. This often happens through innovation. This is why innovation is so important. So they innovated, and now they have, like, for example, for the same cost, a company finds better materials, which gives them a longer range battery for battery electric vehicles, BEVs. And so now they have the same manufacturing cost, but their vehicles have higher performance quality because they go for longer range. They just found a new chemistry for batteries, right? That'll be moving the whole frontier out and jumping to the new frontier, leaving everybody behind in the dust, right? So that's called betterment, to jump high here. So so this theory of efficient frontiers, that there's an efficient frontier. If you're below it, law of cumulative capability will apply and you can improve. If you're on it, you can do positioning until you do innovation to do betterment. Okay, so this theory kind of combines and explains what's happening with all of these patterns that were observed. Here I'm just explaining what I already explained about these 3 terms, right? So these are 2 theories in operations management, examples of some theories, and I think the article makes some very interesting points, gives you an idea of what theory is, gives you an idea of, this framework of thinking of hypotheses, probabilistic knowledge, what a theory is, will help you to interpret the papers you read. You'll see papers either trying to test a theory by deriving hypothesis from it and testing hypothesis empirically, or you'll see papers observing new phenomena and deriving hypothesis from observations, and then trying to see if these hypotheses hold across a range of companies or a range of situations. And then they'll say, oh, these hypotheses hold, there's empirical evidence, and now the explanation for these hypotheses is going to become a new theory or a modification of an existing theory. So you'll see papers do these things. So I think this is a very important paper which lays the groundwork for you to understand other research in operations and supply chain management.